Everyone, I'm Gaetano Di Levrano, and I'm going to present you my research activities related to the design and testing of a motor for transportation. First, something about me. I'm currently a PhD student at last year at Politecnico Torino, where I received both my bachelor and master degree. My research area covered design and testing procedures of electrical machines with focus on automotive application. I was also a PhD visiting student for 6 months this year at McMaster University, Ontario, Canada. I have 11 IEEE publications and 2 submitted papers. I designed 4 prototypes and tested more than 5. I was part of 3 research contracts with industrial partners, and I am one developer of the Serial Design platform. I was also teaching assistant for 2 years and supervisor of 9 students for their thesis. Research activities are motivated by the increasing attention of the automotive industry for high-power and coupled electric machines, so it's mandatory to contemplate magnetic, mechanical, thermal aspects in the first design stage. Moreover, an advanced thermal management is needed for a full exploitation of the torque capability, and nowadays the permanent magnet system machines are the most used machines for this kind of application. The same framework is SIR, and it is an open-source method-based framework for design of synchronous motors. The key contributions are the XB design plane, the flux map-based scaling, the short-circuit current determination, the magnetic and structural co-design, and the custom geometry import and simulation. The design procedure using the XB design plane proposed. X is the ratio between the stator rod diameter and B is related to the magnetic load. The plane is analytically computed and then corrected in 16 points with field simulation. Each point of the plane represents a different motor. The input are the dimension and the current density of the motor, and the first output is the torque and power factor plane. In the green area, all the machine fulfill torque and power specification. Then imposing the inverter limits, the feasibility area is shown for each possible number of turns. Before selecting a machine at the intersection of the torque and number of turn area, the last plane shows us if the motor is safe against the demagnetization in the worst case scenario. If the motor does not fulfill the specification, the plane can be faster computed by adjusting the motor length or by changing the current density. Moreover, other indicators can be added to the plane. Now, the same procedure by scaling is shown. Starting with the reference machine and imposing a new maximum speed, the diameter of the new machine that ensures the same mechanical stress is retrieved. Then, imposing the vertical limits, the length and number of turn plane allow us to properly select the machine that fulfills the torque and corner speed or power specification. Finally, the cooling channel are scaled to guarantee the thermal flow of the coolant, or the thermal network is used to retrieve the continuous operating point and start condition. At the end, the efficiency map of the new machine is computed. Liquid fault is a reference fault for permanent magnet motors. It's useful to verify the risk of irreversible demagnetization to size the mechanical shaft and to check the feasibility of the active safe operating mode. The goal is to propose a methodology for steady state and transient solution that is based on flux map and is fast and accurate, and introduce the hyperworst case peak current estimation that is defined as the current against the permanent magnet that induces the flux linkage amplitude equal to the initial one that is represented in light with a light blue square in the figure. The short-time thermal transient is a testing procedure for the experimental measurement of the winding capacity and the thermal equivalent resistance. This approach is effective for industrial motor drives but tends to favor a power density motor as in traction. So an improved procedure is proposed where the energy function of the overall temperatures is fitted with a third-order Taylor series expansion instead of a linear model, and a second-order lumped parameter thermal network is used to retrieve the resistance instead of a third-order one. Some experimental results. Flux and efficiency maps are computed at Politecnico Torino using a data logger, a custom inverter, and at McMaster University using a power analyzer, a commercial inverter. Here some experimental results of flux map and efficiency maps. Here you can see the validation of the short-circuit current determination both in transient and steady-state operation. Dealing with the thermal test, the retrieved parameters of the original improved procedure are reported in blue and red respectively. Then these parameters are used to calibrate a winding hotspot observer. The predicted hotspot temperature is reported in red and obtained from the green measured temperature, while the measured hotspot temperature is reported in red. To conclude, two fast and accurate procedures for permanent magnet motor design are proposed, as also a method to determination of the short-circuit current, and an improved short-time thermal test procedure to experimentally retrieve the thermal parameter of the machine. All is experimentally validated and the field procedure are included into series. Thank you.